Here are summary statistics for randomly selected weights of newborn girls. The sample size n is equal to 36. The sample mean x bar is equal to 3,216.7 grams. The sample standard deviation is 688.5 grams. Use a confidence level of 95% to complete parts A through D below. Okay, so for part A, we want to make sure to determine what is the critical t value. So in order to find the critical t value used for the margin of error, we first need to determine the confidence level. So we know that the confidence level that's given is 95%. So 1 minus 95% is the same thing as 1 minus 0.95, which gives us 0.05. Then we're going to take alpha and then divide that by 2. So if we take 0.05, divide that by 2, we get 0.025. So now that represents the area in the right tail of the t distribution. So let's go ahead and draw the bell curve just so we can see a picture of what that looks like. Over here, we're looking for the critical value that has an area of 0.25 to the right. Okay, so if we go ahead and then just shade that, we know that this is what we're looking for in order to be able to find the critical t value. Okay, so what we're looking for is we want to find the probability of when that t critical value is greater than or equal to the value that we're looking for is going to have an area of 0.025. Okay. Now, the other thing that we need to know when we go ahead and do this is that we need to determine the degrees of freedom. So the degrees of freedom is equal to the sample size minus 1. Well, the sample size in our problem is 36. So 36 minus 1 is going to give us 35. Okay, so now what we're going to do is open up StatCrunch. And since we want to find the critical t value, we're going to go to Stat, Calculators, and then scroll all the way down to t. And then we want to make sure that we're shading the area to the right. So we're going to go ahead and make sure the inequality is pointing to the right. And the degrees of freedom over here is 35. So we're going to put 35. And then we want to find this critical t value, but we got to put in the area, which is 0.025. So now if we get our critical t value, we're going to round that to 2 decimal places and we get 2.03. So therefore we get 2.03 as the critical t value. So let's go ahead and put that answer in here. You get 2.03. Now the next question is to find the margin of error. So how do we find the margin of error? So for part B, we're going to use the following formula. Okay, we're going to take the margin of error is equal to the critical t value times the sample standard deviation divided by the square root of n. So we determined that the critical t value is 2.03. If we come up here and look at the question, we can see that the sample standard deviation is 688.5 grams. So that's 688.5. And we know that the sample size in the problem up here is 36. So let's go ahead and find the margin of error. So we're going to take the critical t value, which is 2.03. We're going to multiply that by the sample standard deviation of 688.5. And then we're going to divide that by the square root of the sample size. So let's go ahead and do that. Alright, so in the numerator, we're going to take 2.03 and multiply it by 688.5. And we're going to divide that by the square root of 36. Well, the square root of 36 is 6, so we're going to divide that by 6. And therefore, that is the margin of error. Now, it does say to round one decimal place as needed, so this becomes 232.9. So the margin of error is 232.9. Let's go ahead and check our result. 232.9, and there's our answer. Okay, now we want to be able to find the confidence interval estimate of the population mean. So before we do that, we need to first check the requirements to construct a confidence interval to use to estimate a population mean are met. So the requirements are shown below. Well, the sample is a simple random sample, and either the population is normally distributed or n is greater than 30. Well, we know that n is 36, so it is greater than 30. And since the sample is a simple random sample and the sample size is greater than 30, the requirements are satisfied. Okay, so now we need to write down the given information. So from the problem, we know that the sample mean is 3,216.7 grams. And we just determined that the margin of error is 232.9. So now we're going to use this formula to find the confidence interval for the mean. So we know that on the left side we have 3,216.7, and we're going to subtract 232.9, and then that's going to represent our lower limit. On the right side we have 3,216.7 plus 232.9. And so now we just need to calculate those values. So if we take 3,216.7 minus 232.9, we get 2,983.8. So that's 2,983.8 for the lower limit. And then for the upper limit, we have 3,216.7 plus 232.9, and that gives us 3,449.6. So let's go ahead and put our values in here. So the lower limit is 2,983.8 grams. And the upper limit is 3,449.6. Let's check our result. And there's our answer. Okay, the next question now says, write a brief statement that interprets the confidence interval and then choose the correct answer below. Okay, well, when interpreting a confidence interval estimate of the population mean, know that the confidence level gives the success rate of the procedure used to construct the confidence interval. So we would say that one has 95% confidence that the interval from the lower bound to the upper bound contains the true value of the population mean weight of newborn girls. So that means it's going to be